Howdy folks, I'm Keith Bowen. This is Hard Rock University, back here at Montana Bee doing some other stuff. And as you've heard before, the ore here is just not going to work for gravity separation. So I'm going to be doing a lot of work on leaching. And while in some ways leaching is fairly simple and straightforward, in other ways it gets a little bit more complicated and technical. So to try and make it more interesting for the people who aren't actually going to do it or thinking of requiring to do it, while making it informative enough for those who are potentially interested in doing it, I'm going to present the information in the leaching stuff in 3 different layers of complexity. Number 1 will be just the basics, why we're doing whatever it is we're doing. Number 2 is exactly how we're doing it and why we're doing exactly how we're doing it. And number 3 will be, in many cases, things like formulas, calculations, and stuff like that. And what I'll do there is I'll put the formulas, etc. on the screen, and so that anyone who's serious about it and needs to do this and needs that information can literally just freeze frame it, copy it down, or whatever. So I'll try and move it quick enough and at a basic enough level so that those people who aren't seriously in need of this information don't get bored to death, and those who do need it can get what they need. This is how I'm going to do it. Now, the reason we're looking at leaching for Montana Bee is very, very simple. And this applies to all ores in general. The particle size of the gold determines, to a great extent, what will work. And the rock around it determines, to a great extent, everything else about what will work. This particular ore, the gold is extremely fine. Like 80% of the gold is 1/10 the size of powdered sugar. Extraordinarily small, simply will not settle. I mean, you'd have to super centrifuge it to get it to settle at all, and then to try and get it to settle more than a much larger rock particle is impossible. The other thing is that because it's so small, to get the gold broken away from the other rock, you have to grind the rock all down to the size of the gold, basically, or somewhere close to it. And oh my lord, the cost, complexity, and difficulty of grinding rock to something that makes powdered sugar look coarse is just simply beyond the ability to make a profit, you know, by orders of magnitude. So let me go ahead and show you the first, there will be some graphs and stuff, but I'll explain it while we're looking at the graphs, etc. And let's see how this format works out. Now, one of the things you'll need to do is figure out what's known as slurry density, because this determines how big a containers you need to mix stuff in, etc. So I'm starting with 25 grams of ore and 50 milliliters, which is 50 grams of water. Now that's the standard ratio that we've been using on the tests. I'm going to put it in there slowly so that it wets itself thoroughly and doesn't clump, because if I stir it afterwards, a lot of it will stick to the sides of the graduated cylinder, and I can't wash it down because then that would add water. So there we go. And that's the 60 line. I'm getting about 58 at the bottom of the meniscus here. So call it 58 to 60 milliliters total with 75 grams in it. So let's do the calculations now. So if we take 75 grams divided by 58 cc's, you wind up with 1.3. If we take 75 divided by 59, we get 1.27. So for safety margin, we'll go with a 1.25 grams per cc slurry density, and that means every gallon of slurry would be 10.4 pounds. Every cubic foot of slurry would be 77.5 pounds. And each gallon of slurry would contain 3.46 pounds of ore, and every cubic foot of slurry would contain 25.8 pounds of ore. So now we have the numbers that we need to figure out the volume of containers when we're doing our agitation, leaching, and stuff like that. How much slurry, how much ore can we process with what size container using the slurry density that we're currently using. Happy prospecting and keep it safe out there.